Hey everyone. All right, so we're gonna start our second session. For today, last session, we had a problem with a forward declaration for the class, and I googled it, and I turns out you can't forward declare a class, which is kind of interesting. Um, so yeah. Anywho, one thing I want to cover or talk about before we start with SFML is that make sure whenever you are creating a variable like this, like int damage, you give it a value. Don't create a variable and not give it a value. The reason for that is that when you create a variable, it will be stored in memory somewhere. And if you manage to when that variable is stored in memory, the value of that variable will be whatever value it was. Okay, that was a that was horrible. That was horrible. Let me try this again. Whenever you create a variable, it will be stored in memory. The value of that variable will be whatever value was in memory at the time. So you always want to make sure you give it the value 0. And so let me just draw this. Let me see if I can make it sound a little bit better. All right. So let's assume that this is memory, right? You have a box, right? So this is your memory, right? When I create the variable int HP, right? Now in memory, there are a lot of values that exist from previous applications. So for example, this block has the value 5. This has the value 10 minus 20. This has a string that says let's do x, right? This has like false, 55 minus 10 minus 100, right? And so on and so forth, right? You can see that all these values are left over from previous applications that were ran by the computer. So whenever you create a variable like this HP, well, the operating system will go and find out space for this variable. So it'll be like, hey, you know what? I'm going to put it in here. I'm going to store HP at this location. I need to do HP. The problem is this location already has a value, which is the value 5. So now HP has the value 5 all of a sudden, even though we never said HP equal to 5. But because the operating system decided to store HP here in memory, and there's leftover values like this, HP is now all of a sudden 5. So that's why whenever you create a variable, always make sure you give it the value 0, or initialize it to a default value of your choice. It doesn't have to be 0. You can give it whatever value you want. The important part is don't just do HP and then semicolon and that's it. You need to make it equal to something. Just because if there's leftover values from previous applications, HP is not assigned to that. Now you override that value with whatever value you want. So that's very, very important to do. That's something I forgot to say. So never do this. Always say health equal to 0. Now, before I jump into SFML, one more thing that I would like to cover is that convention, writing convention or code convention. Now notice what I've done here. Damage, there's the letter D is small. Health, the letter H is small. However, for functions, K is the letter K for kill is capital. The letter H is capital. The letter W is capital, right? For these functions. So why are these capitals but these small? Well, normally, whenever you have a variable like this, variables should be small letters, all small letters. So like this, damage or health. For functions, they should be capital letters, like kill, health, walk, all capital. So that's a convention that's very important. Now, what if the variable is made of two words? So for example, let's say attack speed, right? So int attack speed. Do we just keep it like this? It's hard to read, right? I said never do this, do equals 0 always. Attack speed is hard to read because it's all one word, right? It should be two words. So what we do is we make the S capital. So the next the first letter in the next word is capital, like this. So attack speed. Another example would be first name. So string first name equal to null, right? Or empty string. Let's do std, which is important, right? So first name. So the first letter in the second word is capital, which is important, right? So that's one convention. Other programmers like this convention. So first underscore name, attack underscore speed. It doesn't matter what convention you pick, as long as you're consistent. Pick a convention and stick with it. What I'm going to pick is this convention. I like this one, and I stick to it. Notice when we're doing enemy, the class name, I don't do small e enemy, I do capital E enemy. That's a convention, that's very important. So variables, small letters, functions, capital letters, classes, capital letter, objects, which are also variables, small letter, right? So just keep those in mind. So always try to be organized, make your code clean and well named. Your variables should be well named. That's really important. All right. With that out of the way, we can start with SFML, right? So let's do that. All right, so what I'm gonna do here, I'm gonna go to Google, right? And I'm gonna go to the SFML website. So SFML. So SFML stands for Simple Fast Multimedia Library. Now you might have heard this term multiple times from me, which I've said multiple times. The term is library, right? And you might not know what the hell a library is, right? So the term library stands or what it means is that a library is just a bunch of code that is that cannot be executed, right? It's just a bunch of, or cannot be executed, sorry. It's a bunch of code that you give to other programmers to use. So let me give you an example. I go back here. Right. Let's say you're making a game. You're making a 2D game. So this is my 2D game over here. 2D game. Right? And you've written some code in the 2D game. You've compiled it, you linked it, and now let's call this game RPG. It's called RPG for whatever reason. So now the linker is going to create an application for you called rpg.exe. This is not a library, right? Because you can specifically run it. It has an exe file. Your code can be executed when you run the exe file. A library, on the other hand, is similar but different. So let's say this is a library. There's some code in here, right? It's a library. Let's say this library is also called 2D game, and you named it RPG. Now, this library will not have the extension .exe. It will have the extension .lib for library, short for library. If you try to run it, no program will open. It's not gonna run. This application or this library cannot be executed like an exe file. However, this code that I've written can be included in other applications. So for example, this 2D library will be included inside this project, which I can use, and this project can be ran. I can open it and I can run it because it's a project and there's an exe file. So a library is just a package with a bunch of code that you can include in other projects. So SFML, right, is a library. It's a bunch of code that we include in our project, and we can run our project as an exe. This code will help us create a game. It's written by someone or some people, and it'll make our life much easier to write that code, to write our game, right? So a library is just a bunch of code we include in our project. That's essentially it. Now, there are two types of libraries out there. There is a static library, and there's a dynamic library. Okay, we're not going to create our own library, at least not now, maybe at some point in the future. But you need to understand these two terms, static and dynamic library. What's the difference? Well, both of them are library, both static and dynamic. They're both libraries. They both have a bunch of code written by some other people. The difference is a static library, whenever you include it in your project and you build your project and you run your project, that library code will be saved inside this exe file. Meaning if your library is 10 MB, 10 megabytes, and your exe by default without the library is like 2 MB, and you include your library in your project, now the size of your exe file is going to be 2 plus 10 MB, which is 12 MB. So a static library, the code that was written by someone else, will be injected or will be saved inside your exe file, right? That's the static library. And that's sometimes good, that's sometimes bad, depending on the situation, right? For us, specifically, we're going to include SFML statically into our project. So that means the code of SFML will be saved in our exe. Now, we'll talk about advantages and disadvantages. Let me explain dynamic library first. Okay, so that's the static library. Static library, your code is in the exe. Dynamic library, your code, or the code of the dynamic library lives in a special package called a DLL file. And a DLL file stands for Dynamic Linked Library. And you might have seen a lot of DLL files. So for example, if I go to, I don't know, let's go to here. Let's go to my Steam library. There's a steam.dll. There, it exists. If I go to Steam Apps, Common, I don't know, let's open a game. Let's go to Doom. Doom has a bunch of DLL, right? These are all inside this file. There's a bunch of code that gets linked with the game, right? So now your code lives in this file called a DLL. And when you run the game for the first time, the game will look for this DLL file. It will search for it. if it finds it, it's going to link with it. So the linking part, the linking of the linking between the game and this code or this library happens, we call it at runtime. Runtime means when you run the application, right? So the linking process happens at runtime. Your application, when you first run it, it's going to look for this DLL and it's going to link the code at runtime. However, with a static library, the linking happens when you compile your application, or when you're compiling your application in Visual Studio. So that's an important distinction. If you delete this DLL and try to run the game, you are going to get an error, and the error will say something along the lines of, "Hey, I could not find this DLL, and I cannot run this game. Therefore, I'm just gonna close." Now, the question is, why would you make a dynamic library? Why not just keep it static and put everything in your exe, right? Now, the idea behind the dynamic library is that since the linking happens at runtime, what I can do is this library, which let's say it's SFML, right? Let's say it has a function called draw, right? It has a function called draw. Now in SFML 1.0, this function, it drew a triangle, right? And so when your game linked with SFML, and in your game you're calling draw, you're using the draw function, right? That's gonna draw a triangle. Now in SFML 2.0, this is just an example, by the way. You still have the draw function, but now when you call the draw function, it will draw a circle. So this draws a triangle, this draws a circle. Now the cool part is, as a developer, I don't have to recompile my entire game. Now recompiling my entire game might take anywhere between a minute to 2, 5, 10 minutes, depending on the length of the project. Sometimes they can take hours or days to compile a project. Like if you go and try to compile Unreal, it'll probably take like hours to compile. So let's say I want to update SFML, right? I want to update the version of SFML. I want to update from 1.0 to 2.0. Well, I don't have to recompile my game, right? I can just replace this file because the draw function is the same. It didn't change. It exists in both, in the old version of the DLL. So this is my DLL, and the new version of my DLL. So the draw function exists in both versions. However, I want to update it so the new version will draw a circle. So I can just copy the DLL and paste it in my project, and I don't have to recompile anything, which is super cool because the linking happens at runtime, right? So that's pretty cool. That was the idea behind a DLL file. Why would we want to do dynamic libraries? It's because we can just replace the library and our application will just link to it at runtime. Now, if there's a brand new function, right? So let's say in SFML, there's a new function here called, I don't know, kill, right? Now this function didn't exist in here, right? And because it didn't exist, I never called kill here. I never did that. Kill was never called in my game because it never existed. Because when I first linked my game with SFML, whenever I was developing my game, I was using SFML 1.0. So kill never existed here, and I never used it in my game. However, in 2.0, the kill function exists. And so there is no way for me to use this new function without recompiling my entire game, right? Because I need to call this function in my game, and I can't do that without compiling my game. So if a new function was added, and if I want to call it or use it, I have to recompile the entire game. So there's no way around that. Another example is, for example, if draw in here, let's say it didn't take any inputs, right? Didn't take any inputs. However, in here, it took an input. So in here, it takes an input called shape. So it asks you what shape you want. So this always drew a triangle. And in here, you can specify the shape, which can be either triangle or a circle. If you simply replace the DLL, right, your game will crash because the DLL expects an argument of type shape. It expects you as a programmer to provide those parameters. But since all you've done is copied and pasted that DLL and you didn't recompile your game, it's going to crash because, well, you didn't provide any arguments, right? So that's also an important thing you have to keep an eye on. Right? So that exists. So sometimes you can't just simply copy and paste the DLL and just be like, hey, cool, everything works. Sometimes you have to recompile the game, right? Now, so that's dynamic libraries. And dynamic libraries are really useful because they allow modding support. You can add modding support to your game. You can basically say, whoever is going to create a mod for my game, in the DLL, it has to have a function called run mod, for example, run mod. And this run mod will be called by my game. So if you're making a DLL, make sure that run mod is there. And I can have multiple different mods to run by just copying DLLs, which is super cool, right? So that's also something you can do. So those are the advantages of a dynamic linked library, is that you can have it in a DLL and you can update the DLL without recompiling your entire game for the most part. And you can add modding support and things like that. However, the disadvantage is that if the program couldn't find that DLL, it will crash and will not run, right? And that's important to note. Now, what is the advantages and disadvantages of a static library? Well, for a static library, the advantages is that if like there's nothing to delete, there's no DLL to delete, so you're guaranteed that the code will always be in the game. So there's no files to delete, which is cool. Disadvantage is that your exe file will be bigger because this code is now inside the exe file. And if you want to change anything and you want to update your library, you have to recompile your entire game. So that's something you just want to keep an eye on. For our game, we're going to go with the for our game, we're going to go with the statically linked library. So we're going to link SFML statically. And any library can be linked statically and dynamically, right? You can pick if the library supports it, of course. But for our case, we're just going to do it statically, which is useful, right? All right. So now I can go to SFML and I can download the game.